want to give you this example. So this number G is a particular property of the electron particle. And I'll quickly explain what it is. The electron is a particle, and it turns out the electron spins. It orbits rather like the Earth orbits. And it has an axis of spin, and you can change the axis of that spin. And the way you change it is you take a magnetic field, like this, and in the presence of a magnetic field, the electron will spin, the electron will stay in one place, but spin, and then the axis of spin will slowly rotate, like this. It's what's called precession. And the speed at which the axis of that spin precesses is dictated by this number here. Okay? So it's not the most important thing in the big picture. However, historically, this has been extremely important in the history of physics because it turns out this is a number you can measure very, very accurately doing experiments. And so this number has sort of acted as a testing ground for us to see how well we understand the theories that underlie nature, and in particular quantum field theory. So let me tell you what you're looking at here. The first number is the result of many, many decades of painstaking experiments measuring very, very precisely this feature of the electron. It's called the magnetic moment, for what it's worth. And the second number is the result of many, many decades of very tortuous calculations, sitting down with a pen and paper and trying to predict from first principles, from quantum field theory, what the magnetic moment of the electron should be. And you can see it's simply spectacular. And there's nothing like this anywhere else in science, with an agreement between the theoretical calculation and the experimental measurements. It's sort of, I think it's 12 or 13 significant figures.